Assalamu alaikum everyone. In this video, we will learn about the introduction of computer and microprocessors. So let me explain you first. Like in this video, we will understand the internal organization of a computer, CPU, memory, and input output, types of memory, how CPU connects with memory and input output devices, microprocessors versus microcontrollers, embedded systems, and AVR microcontroller family. Like it's an overview of this whole video. Next, we will discuss about the internal organization of a computer. Like as we know, every computer has three main parts, that is CPU, memory, input and output devices. Input devices includes keyboard, mouse, sensor, and output devices include LCD, printer, and robotic arms. The CPU is the brain of the computer. Memory stores data and instructions. Input and output devices helps the computer communicate with outside world. Next part is memory basics. Like memory is anything that can store information, retain information, and recall information. For example, hard disk, RAM, even a piece of a paper is an example of memory. Memory characteristics include capacity, organization, and access time. Like capacity may how many bits it can store. For example, like 128 kilobytes and 256 megabytes. And or for organization, example is 128 cross 4 memory means like 128 locations with 4 bit in each location. Then access time, how fast data can be read from memory. Then we have types of semiconductor memory. Memory is divided into two parts, as we all know, RAM and ROM, random access memory and read only memory. So सबसे पहले like RAM में आता है SRAM, static RAM, which includes which is made of flip flops, very fast, no refresh needed, and it's inexpensive. It's consume high power. And then we have DRAM, which is dynamic RAM, made of capacitors, needs refreshing and slower than SRAM. It's cheaper and have high capacity. Then we have NVRAM, non-volatile RAM, which is fast, keeps data even without power, and it's an expensive one. Then we have ROM, read-only memory, like mask ROM, programmed by manufacturer. PROM can be programmed only once. And then we have EPROM, also known as EPROM or EPROM. I don't know the exact pronunciation. Then we have EEPROM, ठीक है. Then flash memory, EPROM arrays using ultraviolet light takes about 20 minutes. Entire chip erased. And double EPROM includes electrically erasable, can erase byte by byte and faster than EPROM. Then we have flash memory, entire device erased at once, very common in USB drives. And then आता है हमारे पास CPU and its internal parts. CPU performs instructions step by step. Main parts inside CPU are program counter, PC, ALU, arithmetic logic unit, and registers and instruction decoder. So PC holds address of the next instruction and performs ALU performs calculations and registers small fast storage inside the CPU. Instruction decoder understands instruction, and the CPU works using fetch, decode, and execute cycle. Okay. Then we have connecting memory and input output devices to CPU. So CPU connects to memory and input output using buses like address bus, data bus, control bus. Address bus selects memory location and data bus transfer data, and control bus controls read write signals. There are two main methods like peripheral input output and memory mapped. Peripheral separate address space for input output, and memory mapped may input output devices share memory address space. Then we have number systems. So computer use different number systems, decimal, binary, hexadecimal. Binary addition is used in डिजिटल सर्किट्स एंड कंप्यूटर आर्किटेक्चर आता है, फिर वो होता है हार्वर्ड आर्किटेक्चर एंड वॉन न्यूमन आर्किटेक्चर, सेम memory for data and instruction, same bus for both. For example, Pentium processor or Harvard architecture, separate memory for data and instructions, separate buses used in most microcontrollers, microprocessors. Then we have a difference of microprocessor versus microcontroller. So microprocessor only CPU on chip होता है, and RAM includes RAM and ROM, input and output external होते हैं इसके, और used in PCs, laptops and servers. For example, Power PC, Pentium. And then microcontroller includes CPU plus RAM plus ROM plus input output devices plus timers on one chip. Sorry, it was only input and output, not devices. Used in embedded systems, for example, PIC, AVR, ARM 8051. Used in remote washing machine, TV remote, cars, and robots. Then embedded system. An embedded system is a system controlled by a microcontroller inside it, as we all know. For example, cars, airbags, engine control, mobile phones, microwave oven, security systems, and digital cameras. They perform specific dedicated tasks. Then we have AVR microcontroller family. AVR stands for Advanced Virtual RSIC, and the AVR types include Tiny AVR, Mega AVR, X Mega AVR, 32-bit AVR. Tiny AVR is a small of low cost and low power, more memory and more I/O for Mega AVR, and X Mega AVR is basically more high power and performance, and then 32-bit AVR is powerful. For example, at Mega 32 and at Tiny 44, then we have a difference of RISC and versus CISC. CISC consists of large instruction sets, complete complex instructions, and variable length instructions, and RISC consists of small instruction sets, simple instructions, fixed length instructions, and faster execution. AVR is based on RISC architecture, and then we have a conclusion. So today we learned about internal structure of a computer, RAM and ROM type, CPU internal parts, bus system, microprocessors versus microcontrollers, and embedded systems and AVR family. This is the foundation of a computing and embedded systems. Overall, understanding these basic concepts of CPU, memory, architecture, microcontrollers, and embedded systems forms the foundation of a computing and digital electronics. Thank you so much for your time.